Hey everyone, welcome to our next video. This one is 5.3. It's actually not too long. So 5.3 is area of a triangle. And so this one I'm actually going to kind of show you like where it comes from and stuff like that. So usually the area equation we would use is a half times base times height. Now the issue with that equation is what if you don't know the height? So let's go ahead and look at a triangle. Now you can always draw the height of any triangle, but let's say you know like this angle A, and then we know B, and then let's say we know C. I mean, you always have to be given at least 3 pieces of information. And we know from law of sines and law of cosines that even if it's not like this information that we're about to use, we could find it. Your height is always drawn from highest point to the base. So this is the height of my triangle. Something else you can notice is that the height and the base intersect each other perpendicularly. So there's a right angle right there. So what I want to do is I want to come up with something where maybe I can replace this h. I did not mean to erase that. Go back. There we go. So I want to maybe get rid of this h, like replace it with something else. So what I can use is I can use this angle A to help me out. So my H is my opposite side from A, and then C is my hypotenuse. Now, usually we don't have a hypotenuse when dealing with oblique triangles. The only reason we do right now is because of this little triangle right here that has this right angle because of the height. So sine of A would be equal to H over C. And then I can solve this for H and say C times sine of A equals my height. And so then this I can replace into my area equation. So now I have area is equal to a half times B, or the base, times C times sine of A. Now usually I wouldn't write it with that many, multiplications and stuff. I would just say a half BC sine A. And your equation could change a little bit depending on, what sides you have and which angles you have. All you really need to know is that it follows a side angle side relationship. So to use this formula, you just need two sides and then the angle between those two sides. If you write it differently, so you could write it like this. Let's say I have sides A and B. So the angle between those would be C. And let's say that I have sides A and C. Then the angle between them would be B. So this is just a way to find the area of a triangle if all you have is some sides and an angle. So let's go ahead and do our first example. This says find the area of this triangle. $92.5, 48.5, 6, and 8. And I'm going to go ahead and label this as this is B, so this is B, and then this is C, so this is C. I think in the original problem that I wrote, I just like gave the information like written out like this. But just now I accidentally like put it all on the triangle. So either way, but I think we should be pretty good at drawing it on triangles at this point. So now the issue here is we want to find the area. We don't have a height. We also don't really have a side angle side relationship. I have a side and a side, but the angle between them would be right here. However, I can go get that angle fairly easily because I know the other two angles. So first I need to go get that. So I would do A is equal to 180 minus my other two angles. So 180 minus 48.5 minus 92.5. And this tells me that A is equal to 39 degrees. So that helps us out. Now that I have that side angle side relationship, I can find my area. So my area is half, and then the two sides sine of the angle between them. You can also write it out with the formula if you want. I always exercise caution, like strictly using those formulas though, like needing it to be B, C, and A, because it is always possible that maybe you have different angles and sides, and you'll still need to use the formula. So I think it's a little better to understand that it's just a side angle side relationship. Might make it a little easier when the questions change. If I solve all this out, let me go ahead and put area here since I already had A, so I don't want to confuse you there. Is 15.1. I should probably do that up here as well. I didn't even think about that when I wrote it earlier. So if you want to make a little mark here that it's area, I just realized that I put A twice, so that might have been a little confusing. Sorry about that. And then we can also do examples like this one where maybe it's not actually a triangle, but we still use the formula. So I'll show you what I mean by that. So this is like almost a rectangle, but not quite. So the sides across from each other are not the same. The angles are not perfectly 90 degrees. So this is not a rectangle. It's also not a parallelogram because they're not the same across from each other. So this is just kind of a quadrilateral-ish, shape. But it's not regular. It's a quadrilateral, but it's not regular. So if we want to find the area of this, we can go ahead and split this in half. I didn't mean to have the eraser on, my bad. So I can split this in half and then treat each triangle separately. So I'm going to go ahead and draw them separately for us. That way we kind of get the point. So this would be 93.5, 91.5 degrees, 148.7. Those are all degrees on there. So I can find the area of that triangle plus the area of the bottom triangle. And you also could have split it up this way if you wanted to. That would have been fine as well. But be careful. We can't make any claims about like this angle or this angle because I didn't split it like half or anything. But now I can find the area of each one of these using that side angle side relationship. So this one would be a half, 93.5 times 148.7 times sine of 91.5 degrees plus, and then the other one would be a half times 155.4 times 100.5 times sine of 87.2 degrees. So I'm just taking each one, finding the area separately, and then I'm going to add them together. So let me go ahead and do this in my calculator, see what I get. So for this one, I get 6949.34. And then for the other one, I get 7799.53. So then if I add this together, I get 14,748.87 as my answer. And that's it. So I was just taking the total area and I added the first area plus the second area to find that total area. And so you'll have some on the homework like this where you're going to have to maybe like piece out whatever shape you're dealing with and turn it into triangles. That way you can find the area of each triangle and then like add them or subtract them or something like that. And then there's one more formula that I want to give you. This is not something that we have to use, but if you only have sides, there's another area equation we can use. It actually has a special name. It's called Heron's formula. So I guess somebody named Heron made it. And so this is if you only have sides available to you. So first you'd have to find S, which is your A plus B plus C divided by 2. And then you can plug that into the area formula. I don't need you to remember this formula or anything. Truthfully, you can always just find an angle. Like if you're given 3 sides, you can use law of cosines to find one of the angles and then just use the formula we used before. So you don't really need this formula. But if you want to use it, you can use it. Totally up to you. So that's actually it for 5.3. Like I said, it's a pretty quick little section. not very much really to do. It's just, it depends on the shape, you know. You might have to break it up into more triangles or something like that. Let me go ahead and open up the homework to see if maybe there are any other cool ones that I want to do. I don't think so. No, I mean, there's a trapezoid one that has some like radicals and stuff in it. That might be a little hard just to deal with. So some of these ones that say like use Heron's area formula, like when you get to them, you can use the formula or you can just find an angle using law of cosines and then go ahead and use our normal formula. Just remember, you don't have to do the homework the way they say to do the homework. You can use different methods and stuff to figure out your questions. Yeah, so one of these says a triangular piece of glass has side lengths of blah, blah, blah. It gives you some side lengths. Find the area without using Heron's formula. So what they're asking you to do is find an angle using law of cosines, because it's side, 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 and then you can use the normal area formula that we used at the beginning. So just some problems to work on, and yeah, they're not too bad. I was just looking at. Unfortunately, I had to look at them on my computer, so I couldn't really share the screen, but I think y'all will be okay with them. So if you have any questions, just let me know. A nice little short section. I hope y'all are having a good day. Bye bye.